This is Professor Darif Seitz. This Java tutorial is part 3 of File I/O, Object Files, reading and writing objects to a file, also referred to as serializing objects. The object that we'll be reading and writing to a file is this calculation class here. It's actually the objects get written, but the class allows them to be written because in order to write objects to a file, its class must implement the interface serializable. You need an import statement for Java I/O serializable. Serializable, that interface has no methods. Its only purpose is so that a class can indicate that it participates in serialization by implementing that interface. It's like a flag or an indicator of participation. This calculation class is very simple. It has 3 data members, 2 doubles which are operands, and a string which is an operator. It's simply basic arithmetic with a plus, minus, multiply and divide of these 2 operands. There's only one constructor, takes the 3 data members and assigns them. There's getter functions to get the operand as a double, each of them, and to get the operator as a string. There are no setters. This class is immutable, and its toString function displays the operation, operand 1, and then space, the operator, space, and operand 2. First, in order to read objects from this object file, we have to first write them. Here is the class, it's called WriteObjects. It's going to write some objects to a file. It has a main method, so it can run in the system console. Here we're going to be running. First, to create the object writer, to write the objects, we're going to start out with the name of the file as a string, calculations.obj. The extension there just indicates that it's an object file. We have a file object passing in the file name. We have an object writer object that's of type object output stream. And now we are going to have a try block in order to create the object output stream object writer. This will use constructor chaining. You can see the statement here, object writer is a new object output stream, and then in its constructor we pass in an anonymous, an unnamed, just with new, file output stream, and to its constructor we pass in the file that we've instantiated up here. So it's chained together, and this requires a try statement because exceptions can be thrown. We have to catch the file not found exception. If that occurs, we display unable to create object file and the name of it and exit our program by returning. And if we get an I/O exception, we use its getMessage function to display that message and also return. After the try block, we have our object writer available. First, let's create some objects. So calculation objects, 4 of them. We have a 1 plus a 2 here. You can see the 3 parameters, 100 minus 75, 7.0 times 3.14. Remember, they're all doubles. 30.6 divided by 5. So we create 4 calculation objects that we're going to serialize. We print out serializing objects, and then we have a try block where we're going to write them out. We use our object writer, write object method, and the object reference. This write object can throw an I/O exception that we have to catch. So we catch that, and if we do get one, there's something wrong with our program and we want to just exit it with a return statement. Otherwise, here we've finished and serialization is complete. I have a note here that will be of interest. It says it is unnecessary to close the object writer because the program is exiting and the associated resources will be automatically released and any buffers will be automatically flushed. Also, since the close function can throw an exception itself, adding close would either require another try block down here, or worse yet, in the code up here where we're done with it, a nested try block. Because if you put it in the finally clause, it still throws an exception that would have to be caught. So it's unnecessary, and we want to keep things simple, and that's what we did here. Let's go ahead and run this program. First, I have to make sure we have a run and a reader here. I'll have to change over to make sure that I'm using the right main method. Let's do that, and then we'll continue. Okay, I've changed the main method to be to this write object main here. We'll go ahead and run it. We get the output says serializing objects, serialization complete. Now I'm going to bring up this object file in the TextPad text editor to see what was created. Here is calculations.obj loaded in a text editor. Notice it's a binary file. It shows the bytes here and tries to interpret them on the right. We see some evidence of what we're doing, calculation and some numbers there. So it did create the file, and it's not very big actually. Let's go ahead and go back to the source code now. Another point to note before we move on to reading from the object file, going back to the calculation class that's being serialized, there's a note here that's important. Any static class variables or transient variables, which are labeled with the transient keyword, are not serialized. So if you have some data that you don't want to be serialized, then you can put transient on it, or static variables, which are available at the class level, they don't really need to be serialized. So that's an efficiency thing in the serialization process. Now we're going to move on to the reading of these objects from that file. Here we have a class called readObjects, and it has a main method. It references the calculations.object file, that name, and it's going to have a file object for that. It has an object input stream called object reader, and it needs a try block to do the constructor chaining here. Object reader is chained with the file input stream, which takes from the object file. So we have a new object input stream passing a new file input stream using the object file. We catch any file not found exceptions, display a message in case that happens, and return. And also we have to catch an I/O exception. It's also important to remember the order in the catch blocks here. Since I/O exception is a superclass of file not found exception, you must put the file not found first. Otherwise, if it was the other order, it would get a hit on the I/O exception, and that's not what we want here. We want the specific behavior for file not found to occur, so it has to appear first in the list of catch blocks. Next, we go down and display a message that we're going to be reading and displaying the objects. We have a try block here with a while true statement. We need the while true because we're using read object. We need the try block because we're using read object here, and it can throw an exception. But what we do in the while true, we're going to break out of the loop when we get an end of file exception on the file. But in the loop, we use our object reader, call its read object. That gives us an object back, and we need to explicitly typecast it to the type of object we're interested in, which is a calculation. We know that by the context of our program. So we typecast it to a calculation, and then we do a print line on that calculation, which we'll call its toString method, to print out a formatted representation of that object from the file. When we get to the end of file, we'll come down here, we'll be done reading, and we just fall out of the try block at that point. These other exceptions, IO exception or class not found exception, if there's something corrupted in the object file, that would occur. And then finally down here, we print that we are done reading and displaying the objects, and we have a same comment down here that it's unnecessary to close the object reader. We're going to go back now. I need to switch over to the other main so we can run this. Now we're ready to run this reader class program. We'll run it, and we see reading and displaying objects. There, it's obtained them from the file and used the toString on each one of them, and there reading and displaying is complete. So this concludes where we see that we can serialize objects into files for purposes of reading them later.